Micro level. Circular economy and LCA methods. The economic system used to follow a linear approach. Take, make, dispose. But a question arises. Enables this approach responsible consumption and production, or are there better suited strategies available? Instead of a linear approach, the idea of circular economy is to imitate biological cycles by closing the loops in technical cycles. The requirement is to redefine services and products, for example by offering products on a service basis, or extending their lifespan by maintaining and reusing, enabling sharing and integrating recyclable or biodegradable resources. Circular economy is a strategy to create value while minimizing resource use and environmental impacts through reducing, reusing and recycling, thus achieving economic, societal and environmental benefits. But which circular economy strategy is the most beneficial for the environment? Closing loops can cause side effects not considered in advance. For example, reuse of components may add to impact through the additional transport required for collection. Using recycled materials could impact the lifetime of a product due to quality loss. To choose the best strategy among circular economy options, life cycle assessment is a perfect tool to evaluate these options in terms of environmental impacts. LCA is a robust and science-based quantitative tool for the environmental assessment of products, services and business models over their whole life cycle, from the extraction of raw materials over processing to manufacturing, assembly, distribution, use until end of life. Typical LCA questions are: what is environmentally better? Paper or plastic bag? Recycling or in-time use? Or other similar circular economy considerations. Life cycle assessment helps to avoid problem shifting by quantitatively mapping trade-offs, for example, to other life cycle phases. One example being zero-emission cars or the future nuclear waste. Because any activity will have a certain environmental impact, direct or indirect. Therefore, think beyond the obvious. Think in terms of cause and effect, and use a full life cycle perspective, because there is no such thing as a free lunch. LCA is a standardized approach. For its implementation, a number of guidelines and practical supports exist. The ISO 14040 to 14044 guidelines are directed at the compilation and evaluation of the inputs and outputs and the potential impacts of a product system through its life cycle. Additionally, there are handbooks available, as well as different software solutions and associated databases, which help to execute the actual assessment. The assessment can be applied in product development, improvement, strategic planning, public policy making, marketing, as well as other circular economy areas. In the following slides, we will have a closer look at the actual procedure and discuss the different iterative phases of LCA. First step is the goal and scope definition, followed by the inventory analysis, thirdly the impact assessment, accompanied by the actual interpretation. Phase 1. Goal and scope definition. According to ISO 14040, it is the phase in LCA in which the aim of the study and in relation to that, the breadth and depth of the study are formulated. First of all, you have to frame the actual question which you want to answer with the assessment. According to this question, you have to make the right choices and to select the right data sources to perform the LCA. System boundary and functional unit need to be defined therefore. The functional unit ensures comparability based on functionality. As a rule of thumb, you need to choose the function of your system as close as possible to the actual end use. An example for a functional unit would be 1 kilometer of transport for the comparison of different car models. The system boundaries need to be set according to the research question. What is included in our product system and what not? By answering this question, according to the aim of the conducted study, the system boundaries are set. Different approaches are possible. covering the whole life cycle from cradle to grave within the transport sector strikingly well to wheel, or only parts of the life cycle, cradle to gate, here well to pump, or gate to grave, here pump to wheel. Phase 2. Inventory analysis. According to ISO 14040, it is the phase of life cycle assessment involving the compilation and quantification of inputs and outputs for a given product system throughout its life cycle. Within this phase, a flowchart or product system needs to be developed. The contained unit processes need to be specified. The corresponding data needs to be gathered. If needed, because of multiple outputs or several functions, allocation is conducted. To define the system, a flowchart of the product system is created. It is the most technical phase in performing an LCA study. A central pillar is the unit process, which is, according to the ISO, the smallest element considered in the lifecycle inventory analysis, for which input and output data are quantified. A typical example of a unit process is electricity production from coal at a power plant. For the unit process, physical flows of intermediate products or waste for treatment, as well as elementary flows from or to the environment, are collected. The unit processes are then connected to an overall flowchart. This can be infinitely complex. Because of the possible complex character of the flowchart, one faces the challenge of limited time and resources. Missing data for processes might also be an issue. To keep the flow diagram development manageable, there are several solutions available. Make use of existing LCA databases, exert cutoff, for example, do not consider capital goods, estimation of missing data, or focus only on the differences. As a result of Phase 2, one gains the inventory table. It shows all physical interactions between product system and environment. It originates from a calculation procedure usually done by software using matrix algebra, which relates process data to the functional unit by scaling and aggregates over all unit processes in the inventory table. In the case of multiple functional flows, as for example multiple outputs, multiple inputs, reuse and recycling, it allocates the impact accordingly. In the shown example, you can see the different contributions of the life cycle phases: A as car production, to D as car disposal, to CO2 emission. Adding them up, we attain the overall life cycle CO2 emissions. Phase 3. Impact assessment. According to ISO 14040, it is the phase of LCA aimed at understanding and evaluating the magnitude and significance of the potential environmental impacts of a product system. Within this phase, impact categories, corresponding indicators and models are selected and defined. The impacts are classified, which means that inventory data is aggregated in understandable impact categories, for example climate change, and characterized so that all contributing substances are converted into one baseline unit. In the case of climate change, expressed in global warming potential, methane, carbon monoxide and others are converted with a factor corresponding to their climate relevance into carbon dioxide equivalents. Result is an overall global warming potential sum expressed in CO2 equivalents. Optional steps are then normalization of the results, for example showing the results in context of yearly emission data of a specific region, as well as aggregation and/or weighting of results according to specific values. Global warming potential and the effect on climate change is just one example. Other impact categories are available as well. This slide shows the connection of interventions, impacts and damage categories. The shown impact chain is a description of how the starting points, substance flows and physical changes, are connected to endpoints of areas of protection, where we aspire as low impact as possible. To avoid double counting, it is important to make a clear distinction between the different impact categories and between the impacts and the human activities that cause the impact. Environmental interventions are human interference with the environment, for example raw material extraction. Those affect diverse potential midpoint impact categories, for example resource depletion. The midpoint impact categories cover different endpoints where actual damage would potentially occur. The different pathways, reviewed in different levels of detail, and the corresponding cost chain effect are subject to different level of uncertainties. Phase 4. Interpretation. In Phase 4, the results are analyzed and conclusions as well as recommendations are deployed in relation to the goal and scope of the research. Thereby, significant issues of the system under investigation are identified. In the evaluation, completeness and consistency checks as well as sensitivity analysis are used to reduce and assess the level of uncertainty. Uncertainty derives from imprecise and missing data, but can be pushed to a manageable level. Due to the iterative character of the LCA procedure, preceding steps, for example model development, can be repeated if needed. The generated conclusions and recommendations can thus directly be applied in product development and improvement. Which circular economy strategy is the most beneficial for the environment? By conducting life cycle assessment, we can now easily answer this question. Please see the following references for further information. They have been used to create the video. If not indicated differently, graphics are only elaborations. Vector images were obtained from freepik.com.